Hi there guys, just wanted to give you a quick introduction to 8086 assembly language. A lot of people are now using Windows 7. There's a lot of tutorials out on the web that go into the use of a program called Debug, which is available on Windows XP, but from Vista onwards I believe it's not. So what I'm going to do is I'm going to point you in the direction of a program called Phasm. What you need to do to download this is to go onto Google, wait for that to load. I'm running it on a virtual machine, so the everything's running a little bit slow. So Phasm is what they call the flat assembler. It actually includes source code, so it's open source, and you can effectively, it can compile itself, which is an interesting concept. So yeah, okay. So if we just go to Google and wait for it to do what it's doing. Come on. Well, I'll load Phasm up a second. This is the window you will generally see. It's quite a straightforward window. Now this isn't going to be in depth into assembly. It's just going to be like a quick sort of how-to guide, if you would. Right, so into Google we type in Phasm, and we click on this link here, Flat Assembler. Once that's loaded up, you can click on the download link, and they have a version for DOS, a version for Linux, and a version for Windows. Obviously, if you're running under Windows, download this version or another flavour. What I'm going to go through today is for Windows and DOS only. I'll explain why as I'm going through it. But yeah, grab yourself a copy of the flat assembler. I've just extracted the zip file to my desktop. You will end up with this window here. Now, what we're going to do is we're going to create what they call a COM program, which is basically a command interpreted program. So the first line I'm going to type is basically where the program starts off to, and we do this with an org command, which basically stands for origin, and we're going to start at 100H. And what people don't explain to you is how you get that 100H. So if we go into wiki.com file, I'll click on this one, and basically this tells you that a COM file is an executable file, which is a command file. It's an old DOS type executable, but if we scroll down, it tells you here, since it lacks relocation information, it is loaded by the operating system at a preset address at offset 0100H. And then it goes on to give you some more information, worth a read, but not necessary. I just wanted to show you the where I got 100H from. The H on the end stands for hex. Most of the stuff will be using hex as our values. Okay, so what we want to do is effectively a simple hello world for the assembly language. So the first thing we're going to need to do, if you're familiar with the terms printf, system.out.println, sorry, on Java. We need a way of actually displaying text on the screen. The reason why I say that this tutorial will only cover Windows and DOS is because we're going to be using something called interrupt21, which is effectively it's a DOS interrupt. So if we do wiki int21, and as you can see, it's come up with the MS-DOS API. Okay, so we'll click on that one, and we will find where it is. And it tells you here pretty much what the interrupt vectors that are used by DOS are. 20H will terminate the program. It states that 21H is the main DOS API. This is why a lot of create your own operating system tutorials will not use interrupt21H, they'll use interrupt 10, interrupt 16, because that tends to be BIOS calls rather than an actual already implemented operating system call. So what we're doing is it lists here basically the DOS interrupt21 services, and we want to display a string, which in this case is 09H. Now the question is, I could go through the program and say this is how you do it, but it wouldn't really explain it very well. So what we'll do is we'll load up Ralph Brown's interrupt list. And we will load up this page, and somewhere on here is it that one? Files, papers. Nope, can't see it on there. Right, here it is, the interrupt list. So we will look at the interrupt list by number, and you can see from this page that there's a whole host of interrupts, but we're interested in 21. So if we know that it's 09 that we're interested in, so we'll click on this. Okay, so if you look here, it will say DOS 1+, which is the version, write string to standard output. Standard output is basically the screen, sometimes called the console. What you'll see here is AH is 09H. Now AH is a register. There's four registers, four 16-bit registers that you can use, and they are labelled AX, BX, CX, and DX. You can use them as general purpose registers. Interrupts tend to use specific registers and specific parts of the register. For example, you'll see here AH, and you'll see here AL, but I've just mentioned AX. what AX is, it's a 16-bit register that's addressable with two 8-bit registers. And these registers are AH for the high byte and AL for the low byte. Combine them together, end up with a 16-bit register called AX. You'll see here that the two things that are being used is AH and DX with a dollar terminated string. Okay, so basically what we need to do is we need to move whenever you assign something. So we want to assign AH to be 09H. We need to move the value of 09H into AH. And the way we do that in assembly is we use an instruction called MOV for move. So we will move into AH 09. You can put the H on the end because it's a number under 10 or A. It doesn't really matter, but I'll put it in there for good practice. Hexadecimal goes from 0 to 9, A to F. A represents 10, F represents 15. If you had 10H, that would represent 16 in decimal. So you can see why, if we wanted to execute interrupt 10H, that would effectively be the same as putting that effectively, because it's 16 decimal 10H. Okay, so we've done that bit. We have moved 09 into AH. Now the next bit is DS, DX, dollar terminated string. What does that mean? Well, effectively what that means is that the data segment, we're not really worried about the data segment in the DOS-COM format. That's going to be more when you move up to a segmented executable program. So at the moment we can ignore the DS part, and we need to load effectively a dollar terminated string to DX. Now in terms of the registers, as I said there, AX, BX, DX, and AX, BX, CX, and DX. A generally stands for accumulator. B generally stands for base, which is like memory addresses. C is the counter, so you'd use that for loops, for example, and counts. D is the data register, where you would store strings and that kind of information. The accumulator can be used for arithmetic operations, where you're multiplying numbers, dividing numbers, that kind of thing. And it's also used on interrupts for function, for sort of determining which function of the API we're going to use. So DX, we obviously need to move something into DX, but how do we get a terminated string into it? In FASM, there is a convention, as with most assemblers, called a label. So what I'm going to do is I'm going to create a label called str. Now there's two ways of defining a label. This is your standard way, and it's not just used for strings and things like that, it's used for functions as well. So you can effectively call the str function and it's just literally a label. And then we can start typing in stuff like this, for example. If, however, you've only got one line of instruction code, you can do it like this, and that's the same as putting a colon in and moving it down another line. It depends on what you think looks easiest. So what I'm going to do is I'm going to create a string, and the way we do that is we use a method called db, which stands for define byte. And then what we do is we just literally put inside quote marks what we want the data to contain. So for this purpose we're going to type in hello. Can't type today. Hello world! Exclamation mark. And remember, it's dollar terminated. Yeah, so here, look, dollar terminated string. So what we can then do is we finish with that string now, so we can then move into dx str. Okay, so if we look back here, we're moving it into dx, the dollar terminated string. The dollar terminated string is a label str, which when it does its compilation it will get converted into a memory address. So it will basically take that and shove it into as a reference into this. Okay, now all we need to do is call interrupt21h, which is what this interrupt is. Now we need a way to tell DOS to quit the application once we finish with it. Okay, and the way we do that is with interrupt20. Just wait for this to get back. Interrupt20. So interrupt20 DOS terminate program. It does something with the segments which we're not really interested in. The error level will be 0. There's several ways of returning this. You can return it with interrupt21 at 4ch, but it's easier rather than setting registers just to do IT20H. And this is basically it. We'll click run, compile. I'll save this as test. And invalid operand. Invalid operand. That's probably. Oops. Excuse me a second. Yeah. str is a reserved keyword in FASM. So what I will do is I'll just call it text. So it says it's successfully compiled and it's 22 bytes long. Okay, so if we look in our FASM directory now, we will see we have this test file which is 22 bytes long. There's a small problem which we'll address in the next issue, the next video, and that is we run it, it just disappears. That is because we don't wait for the user input before we close out. So what I'm going to do, just to show you that this does work, is I'm going to go into the directory and just type in test, and here you will see it says hello world. Okay, so that completes the first part of the assembly tutorial. I hope everything was clear. Kind of making it up as I go along, but this is generally the textbook Hello World, as it were. Now, as I say, 21H and 20H, these are both DOS API calls. So these are fine if you want to work under Windows or DOS. Under Linux, might not work. I've not tested this under Linux. I don't think 21H exists. But what we'll do is, when we start moving forward a bit more, we'll go through alternatives like interrupt 16, interrupt 10, for example, because you can use BIOS calls to effectively set up the same as what these are doing. Okay, well, thanks for listening, and I'll catch you next time.